Right. Diving into some really cool machine learning research today.
Yeah, sounds fun.
We're looking at this paper called CoLMDriver, LLM-based negotiation benefits cooperative autonomous driving. Pretty much what it says on the tin.
Right.
Using large language models so self-driving cars can actually talk to each other.
Yeah.
To, make traffic safer and more efficient.
Absolutely.
So our main source is the paper itself.
Of course.
But, we'll be pulling in our own knowledge and expertise as we always do.
Right.
So this paper is pretty important because it gets at a big problem with autonomous vehicles.
Yeah, for a long time, the focus has been on single cars.
Right.
Like making sure one car can drive safely on its own.
Right, just navigating its environment.
Exactly. But the future is obviously not just one car. It's going to be...
Yeah, tons of them.
Right. Tons of autonomous vehicles all on the road together.
So they need to be able to work together somehow.
Exactly. Cooperate and coordinate.
Right, and the old ways of doing that?
Right, the traditional methods.
Yeah, they tend to rely on super specific rules and protocols.
Yeah, very rigid.
Which, in the real world with traffic,
things are always changing.
Yeah, totally unpredictable. So these rule-based systems,
they break down.
Yeah.
But that's where these large language models or LLMs come in.
Right, because they can understand and generate language.
Like humans do.
Yeah, so the cars can actually communicate with each other.
Much more flexible.
Right, much more adaptable to all those crazy situations that pop up on the road.
Exactly.
So the researchers here, they introduced CoLMDriver, and it's a pretty big deal because it's the first full system that uses LLMs for real-time negotiation between self-driving cars. And they do it all with natural language, which is really cool.
Yeah, it's impressive.
And what's really interesting from a machine learning perspective is that they have this system with two parallel pathways.
Oh, okay, interesting.
One handles the back and forth of the negotiation, figuring out who goes first at an intersection.
Right, the high-level reasoning.
Exactly. And the other one's this thing they call an intention-guided waypoint generator.
Okay.
And that takes those agreements from the negotiation and turns them into actual driving commands like steering and speed and braking.
So it's translating the language into action.
Exactly. And that's how they get around this problem with LLMs that, they can be kind of slow.
The processing time, the latency.
Right. Exactly. So by running these two things in parallel,
you get the smarts of the LLM, but without sacrificing the speed you need for driving.
Exactly. It's a really clever solution.
Yes.
And to test this whole thing out, they built this new benchmark called Interdrive.
Okay. A new testing ground.
Yeah, specifically for cooperative driving.
Yeah.
It's got all these challenging scenarios that are supposed to be real world driving.
It's like intersections and merging and all that.
Yeah, exactly. Things that would normally trip up those rule-based systems.
All right.
And the results they got are pretty amazing. CoLMDriver just blew the other methods out of the water. It was way better at successfully navigating these tricky cooperative situations.
So the language-based approach really proved itself.
It really did.
That's exciting.
Yeah. And if you think about how this field is developed, it's really cool.
Yeah.
In the early days of autonomous driving research, it was all about
single vehicles.
Right. Each car was on its own.
Just focusing on its own perception and planning.
Right. Just trying not to run into things.
Exactly. But obviously that's not realistic.
No, especially not in a city environment.
Right. Cars are constantly interacting with each other.
Right. So this paper, CoLMDriver, it's a huge step toward acknowledging that and actually building systems that can handle it.
Yeah. It's moving the field in the right direction.
It is.
So let's dig into the paper itself. What do they say?
Yeah, so in the introduction, they lay out the whole motivation behind this, V2V or vehicle-to-vehicle cooperative driving.
Right.
It's all about improving safety and overcoming the limitations of just individual cars.
Because one car can only see so much, right? And it can only predict what other drivers will do so well.
Exactly.
Yeah.
So V2V lets them share information and make better decisions together.
Makes a lot of sense.
Right. But the problem with traditional methods for cooperation, whether it's preset rules or learned behaviors, is that they're not very adaptable.
Right. The real world is just too complex and unpredictable.
Yeah, exactly. So they just can't handle all the different situations that can come up in traffic.
I see.
And, if we look back at the history of autonomous driving research, it makes sense why we're at this point.
Right. How did we get here?
Exactly. So one of the first approaches was optimization-based methods.
Okay.
Where they try to mathematically model all the interactions between cars and find the best possible actions for everyone involved.
So a giant equation for perfect traffic flow.
Yeah, pretty much.
Yeah.
But the problem is These methods need like perfect information about everything.
Which is impossible.
Yeah, you never know exactly what other drivers are going to do or what obstacles might pop up.
Right.
So these optimization methods were just too brittle.
They couldn't handle the unexpected. So what came next?
So then researchers started exploring learning-based approaches,
Okay.
using things like reinforcement learning to actually train the cars to cooperate.
So like teaching them through trial and error.
Yeah, exactly. And these methods were definitely more promising. They could adapt to different situations better.
Right.
But they still had trouble with generalization. Like if they encountered a situation that was too different from what they were trained on,
They wouldn't know what to do.
yeah, their performance would just tank.
I see. So that's where LLMs come in. They have the potential to bridge that gap.
Exactly. They can handle a much wider range of scenarios because they have this vast knowledge of language and the world.
Right.
Plus, they can communicate their intentions clearly, which is something other methods struggle with.
Yeah. That's a big advantage.
And of course, it's not all sunshine and roses.
What are the challenges?
Well, LLMs aren't naturally designed for the kind of precise spatial reasoning that you need for driving.
Right. They're good at language, not geometry.
Exactly. And if cars are constantly negotiating with each other, it could cause delays and, in driving, every millisecond counts.
Right.
And then there's the issue of inference latency.
Yeah.
The time it takes for the LLM to actually process the information and respond.
Right. That could be a real problem in a real-time situation like
Yes.
driving.
Totally. So that's what CoLMDriver is trying to solve.
Right.
Well, first, they use this parallel pipeline to deal with the latency problem.
Okay, so the LLM isn't holding up the driving.
Exactly. And the LLM-based negotiation module uses this really cool technique called an actor-critic framework.
Interesting. Tell me more about that.
So basically, it's a way for the system to learn and improve over time by getting feedback on its actions.
Okay.
So the LLM is the actor, and it proposes different negotiation moves, like what to say to the other cars.
Right.
And then the critic evaluates those moves based on whether they led to a good outcome.
So it's like a coach telling the player what they did well and what they need to work on.
Yeah, exactly. And that feedback helps the LLM to become a better negotiator.
I see. That makes sense.
And then they have this intention-guided waypoint planner.
Right? We talked about that before.
Yeah, and that's the crucial link between the high-level negotiation and the actual driving commands. It takes those linguistic agreements and turns them into specific actions the car can execute.
So it's like the translator between the language of negotiation and the language of driving.
Exactly. And to really push the limits of their system, they created this whole new benchmark called Interdrive.
Right, to test it out.
Yeah, and it's designed to be super challenging. It has all these different multi-vehicle scenarios that are based on real-world crash data.
Oh, wow. So they're really trying to make it as realistic as possible.
Yeah, they want to see how CoLMDriver performs under pressure.
So what kind of scenarios are we talking about?
Well, they've got things like navigating intersections, merging into traffic, changing lanes, all those tricky situations where cars have to cooperate to avoid accidents.
Right.
And they also vary the number of vehicles and the types of obstacles to make it even harder.
So it's a really comprehensive test.
It is. And to measure how well CoLMDriver performs, they use a bunch of different metrics.
Okay, like what?
Well, there's route completion, which is pretty self-explanatory.
Did they get where they were going?
Exactly. And then there's infraction score, which measures how many safety violations they committed.
So like running red lights or speeding?
Yeah, things like that. And then they have this combined driving score that takes all of that into account.
Okay.
But the most important metric is probably success rate.
Which is
The percentage of scenarios where all the cars involved successfully completed their tasks without any major screw-ups.
So basically, did they manage to cooperate without crashing?
Exactly. And the results are really impressive. CoLMDriver achieved state-of-the-art driving scores across the board on Interdrive.
Really?
Yeah, it was significantly better than all the other methods they tested, especially when it came to success rate.
Wow. So the language-based approach really paid off.
It did big time. And they also showed that the actor-critic feedback mechanism was super important for the negotiation process.
Right. That coach we were talking about.
Yeah, without it, the negotiations were much less consistent and effective.
Makes sense.
And to make sure every part of their system was pulling its weight, they did ablation studies.
Ablation studies meaning?
They removed different components of the system one at a time and saw how it affected performance.
Oh, okay. So they could isolate the contribution of each part?
Exactly. And it turned out that every single part was essential for getting those great results.
Interesting.
And then, of course, they had to test how well CoLMDriver performed in real time. Because, in the real world, those LLMs can take a bit of time to process everything.
Right. The latency issue.
Exactly. So they ran the system both with and without explicitly accounting for the LLM's processing time.
And what did they find?
Well, even with the real-world latencies factored in, CoLMDriver still did really well, which shows that their parallel architecture is super efficient.
That's great.
Yeah, it's a really robust system.
So they tested it on their own benchmark, and it did well against other methods, but did they test it on anything else?
Yeah, actually they did.
Oh, cool.
They also ran it on a public benchmark for single-vehicle autonomous driving called Town 05.
Oh.
And to make it interesting, they let the other cars in the simulation communicate their intentions to CoLMDriver using language.
Oh, that's clever.
Yeah, and guess what?
Right.
CoLMDriver actually outperformed the best single-vehicle methods, even though the benchmark wasn't designed for cooperative driving.
Wow. So even when it wasn't strictly necessary, the communication helped.
Exactly. It shows that knowing the intentions of other cars can be really beneficial even in situations that aren't specifically about cooperation.
That's a really cool finding.
It is.
So what do the researchers say in their conclusion?
Well, they basically sum up all their findings and reiterate how effective CoLMDriver is at integrating LLMs with real-time driving control.
Right.
And they also highlight the importance of the Interdrive benchmark for future research in cooperative driving.
Makes sense.
But they do admit that there's still work to be done, like expanding the diversity and complexity of the language interactions in the system.
Right. There's always room for improvement.
Totally.
So what are the big takeaways from this paper? What does it mean for machine learning and autonomous driving?
Well, I think it shows that natural language could be a really powerful tool for creating more sophisticated and adaptable interactions between autonomous agents, not just cars, but maybe robots or other AI systems too.
Yeah, it's a big step forward for multi-agent systems.
Exactly. And it also raises some really interesting questions about how we design and train intelligent systems to communicate with each other.
Right. Like, can we teach them to be more nuanced and human-like in their interactions?
Yeah, exactly.
Like, let's move on to the novel notions segment. What kind of future research directions did this paper spark for us?
Well, one thing I was thinking about is how we could integrate a deeper understanding of human communication into these systems.
Okay, interesting.
Like, imagine two cars approaching a merge lane, and one car says something like, "I'm in a bit of a rush. Would you mind letting me in?" Now, technically, that doesn't change anything about the situation. But a human driver might be more likely to yield just because of the way it was phrased.
Right, they'd pick up on the social cues.
Exactly.
Yeah.
So could we train an LLM to do the same thing, to recognize and respond to those subtle cues and maybe even use them to its advantage?
That would be really cool. It's like adding a layer of social intelligence on top of the basic negotiation skills.
Exactly. And if you think about research in effective computing and how LLMs are getting better at understanding the pragmatics of language.
The meaning behind the words.
Right. It doesn't seem that far-fetched.
Yeah, it's definitely a plausible research direction.
And it could help to smooth out those edge cases where purely logical negotiation might not be enough.
Right, because sometimes you need a little bit of social finesse to get what you want.
Exactly.
What else were you thinking about?
Well, I was also wondering about combining explicit language-based negotiation with more implicit forms of communication.
Like what?
Like subtle changes in speed or trajectory that act as nonverbal cues. So instead of having to say everything out loud, the cars could also communicate their intentions through their actions.
So like a little bit of language and a little bit of body language?
Yeah, exactly. And humans do this all the time.
We do.
It's how we avoid bumping into each other in crowded spaces or navigate those awkward social situations where you don't want to say anything directly.
Right.
So could we apply those same principles to autonomous vehicles?
That's a cool idea.
Yeah.
It would definitely be more efficient in some cases.
Yeah, if the cars can understand each other without having to have a whole conversation every time.
Right.
They could speed things up and make traffic flow more smoothly.
And there's already a lot of research on implicit coordination in multi-agent systems, so it's not like we'd be starting from scratch.
Exactly.
Yeah, I think there's a lot of potential there, but it would definitely be challenging to implement and verify.
Yeah, combining those explicit and implicit channels is tricky.
But not impossible.
Definitely not, and I think it would be worth exploring. But of course, as always with our novel notions, these are just speculative ideas.
Right, food for thought.
Exactly. Who knows what the future of this field will actually look like?
The research is moving so fast, it's hard to predict.
It is, but that's what makes it so exciting.
Absolutely.
So to wrap up this deep dive into CoLMDriver, I think it's safe to say that this paper presents a really compelling vision for the future of cooperative autonomous driving, using LLMs to enable cars to communicate and negotiate with each other. It's a huge step towards creating safer, more efficient, and ultimately more intelligent transportation systems.
Couldn't agree more.
And we highly encourage everyone to check out the full paper for all the juicy details. You'll find a link in the episode description.
Definitely worth a read.
And as always, we want to hear your thoughts. What do you think about the potential of language-based interaction in autonomous systems? Is it the future of driving, or are we headed down a dangerous road? Let us know in the comments.
Looking forward to the discussion.
Thanks for joining us on this deep dive. We'll see you next time.
See you then.